In this video I will be doing exercise 13.5, which reads 2 uniform spheres, each of mass 0.26 kilograms, are fixed at points A and B, which is that figure right there. And part A reads, find the magnitude of the initial acceleration of a uniform sphere with mass 0.01 kilograms if released from rest point P and acted on only by forces of gravitational attraction of spheres A and B. So we're going to start off with Newton's law of gravitational force and figure out the gravitational force of A, which is done here. So we get the gravitational constant, the mass of A, the mass of the sphere being acted on, divided by the radius, which is 10 centimeters, and then we divided by 10 centimeters squared, which gets us the 1.73 times 10 to the power of negative 11 newtons. And then we figure out the gravitational force of B. So we got the same Newton's gravitational equation, plug in the numbers once again, and we get the exact same force since the radius is equal and the masses are equal. And then from there we use a force equation to figure out the horizontal acceleration is actually 0, since both since the forces and masses are equal of the two spheres acting upon the other sphere. So there's that 0. And then we go to the vertical acceleration, which is going to equal f of x equals fg minus fa sine theta plus fb sine theta equals 0. So we rearrange that equation to get fg equals fa sine theta plus fb sine theta. And we simplify it to make it a little bit easier to solve to fb plus fa sine times sine of theta, which gets we plug in the numbers that we previously calculated from these two equations, and then and multiply by 0.6, and then we get 2.076 times 10 to the negative 11th power newtons. And then we use Newton's second law right here to calculate the acceleration, which is acceleration minus f of g divided by m, and we use the negative j symbol to indicate that it is we're talking in y coordinates, and it's negative because it is going downwards. So then we plug in the numbers that we've got right here, divided by the mass of the sphere being acted upon, which gets us 2.1 times 10 to the negative 9 meters per second squared. And that is exercise 13.5.